So Matthew Fairley,
Yes.
who's here, and he's going to talk to us about Hadoop on OpenStack in the Sahara project.
Absolutely.
And not Savannah, Sahara.
Correct.
Because, you know, that's all changed.
We have a running gag that if you say Savannah, you have to put a Bitcoin in the bucket.
A Bitcoin in the bucket.
A Bitcoin in the bucket, which was kind of rough because they've gotten kind of expensive.
Great. Well, I'll let you take it away. Thank you.
Okay, great. Hi. So I guess now for something entirely different. Like it was mentioned, I'm going to talk to you about Hadoop on OpenStack. My name is Matthew Fairley. I'm in the CTO office at Red Hat. Been at Red Hat for about 7 years working on distributed computing of one form or another. These days I'm working on the nice buzzword big data, of which, if you're familiar or not, Hadoop is fairly synonymous with big data these days. So before I start, could I get a show of hands if people are familiar in some way with Hadoop? Okay. Now, can you keep your hands up? Now, I'm curious, how many of you are using Hadoop with OpenStack? Oh, no. We've got some work cut out for us. How about the people who are familiar with Hadoop? Would you actually run it in production? Wow, hey, some of the folks on OpenStack, actually. OK. Well, so this will be somewhat familiar to you, but I got to go through these few slides, otherwise I'm going to be embarrassingly short. So Hadoop, as I usually talk about it, is kind of broken up into kind of like two definitions. I like to term them the narrow definition and the broad definition. So just to set some context here, the narrow definition is essentially just the Apache Hadoop project, which was kind of released by Yahoo based on papers from Google. It's mostly, you can think of it as MapReduce and HDFS. And these days, if you're really up to your Hadoop, you know there's Yarn in there as well for resource management. And then the broad definition is kind of this whole ecosystem of projects that integrate in some fashion with Hadoop. And so they integrate with HDFS or the MapReduce, or now with Yarn, they can integrate just with the resource management and whatever. And they tend to be Apache projects. For the most part, I'm going to talk about the broad definition of Hadoop here. So just to give you an idea of what the broad definition of Hadoop actually looks like, it's fairly common what you see with Hadoop distributions from like Cloudera, Hortonworks, MapR, Pivotal, at one point Intel and whatnot. And you can kind of relate it to OpenStack in a few levels, but OpenStack actually has a handful of benefits. So in Hadoop, the Hadoop ecosystem, everything's pretty much a loosely coupled conglomeration of projects. You can compare that to OpenStack, which is a fairly tightly coupled group of projects. They cover a lot of the same types of functions. So you have things like Embari, which works on kind of like high-level management. You've got resource management. You've got workload management with things like Uzi and whatnot. But each one of these projects actually releases on its own schedule. It has its own separate development teams. It doesn't have an integrated CI. What a contributor on one project is not the same thing as a contributor on another project. There's no kind of like shared communication between them, except for fairly ad hoc things or some efforts like Big Top and the Apache community to kind of like glue these things together. But this is kind of like generally what you get when you're talking about Hadoop for data processing and whatnot. So get a little context with that. The question is, what is Hadoop kind of often used for? So if you're not familiar with this, maybe this will be useful. If you are familiar with it, bear with me. So Hadoop's very popular, very well known for data storage. This is primarily through HDFS, which, if you're not familiar, is a distributed fault-tolerant file system. The interesting thing about HDFS and data storage in Hadoop is that it's not typically your authoritative source of your data. It's often an intermediate source or a source where you dump data, then you process it somewhat, or you potentially do the next thing here, which is you ETL it out into some other repository. So Hadoop's often used for, with MapReduce and Pig and whatnot, doing ETL of your kind of like rough, raw data that you're ingesting from multiple sources. The last thing that Hadoop is used for is actually just directly analyzing the data. And a lot of the Hadoop distributors out there these days actually talk a whole lot about this last use cases with large lakes or reservoirs or fjords or whatever of data and doing the analysis in place. And when you talk about doing analysis in place, this is important for kind of like the big data picture of this. You're really doing things on either like what we call structured or unstructured data. So the distinction between structured and unstructured is a little bit up for debate, but you can roughly think about structured data as information that has some sort of application applied structure to it already. And this is commonly things that are stored in relational databases. This is commonly things that are the output of some sort of ETL process. And then unstructured data is pretty much everything else. And frankly, there's a whole ton of everything else. If you go and look at some of the analyst reports on this, you actually see that there are estimates that say that there's 2.5 or more times unstructured data than there is structured data out there, which means that if you're kind of looking at all the information that can be coming into a business for evaluation, for potential value adds to the line of business or whatnot, is an incredible amount of that doesn't come in a kind of like pre-structured format for you. And the kind of the second point on that is that you can, when you look at the actual rate of growth for this unstructured data and the structured data, the unstructured is actually growing at about twice the rate, which means that in like 3 to 4 years, you'll actually have not just 2.5 times, but 5 times the unstructured data that you have with the structured data. So with this comes some problems with kind of like managing data, as you are probably all familiar with at some point or another here. And one is, how do you go from this unstructured to the structured? And it's actually a very expensive process. It's not just expensive in the fact that there's a whole lot of hardware that's required to do it. There's a whole lot of computational time. But probably the most expensive part of this is actually the human time trying to figure out what the structure is that you want to ingest into your system so that you can do some sort of analysis or some sort of mining of that data. And to compound this, you actually have the amount of data that's being created, especially a lot of device data, a lot of monitoring data that exists today, is actually outpacing the amount of capacity that's being created on a yearly basis as well. So that kind of motivates a little bit this very rough observation, so bear with me, I'm not an artist, that a lot of the data processing that's happening in the kind of like the big data space these days is moving from a model that you see more on the left here, where you have some set of data that you're ingesting through an ETL process into a database, and then you're doing your analytics, your analysis on it, and you're getting some sort of magical value out the other end. With the fact that the data is growing, outpacing the size of the database, you actually have that analytics aspect of the computation happening as part of the ETL, and the data stores, kind of like the structured, persistent data stores, are more augmenting that process as opposed to driving that process. And a lot of this is moving some of the complexity that you used to get by using databases as processing, which meant you had structure and you had an idea of what the question was that you were trying to ask of your data. And you're removing that and you're putting the analysis kind of before all of the structure gets applied. So with that, analysis was hard before, but analysis is like even harder now, to the point where simply finding data sources, if they're external data sources, there's very little consistency between data marketplaces that exist, and even in single marketplaces, there's very little consistency with the quality of the data, the provenance of the data, and whatnot. And you've probably noticed this if you've done some sort of mining of data inside your organization, that you'll find the data is really siloed in different lines of businesses or different organizations, where they kind of view data as incredibly valuable and often sensitive to the organization. They don't necessarily understand what's in there. So you have to kind of jump through a lot of hoops to even figure out how you can access it, what times you can access it, what kinds of analysis you're allowed to do on it, and where you're actually allowed to do the analysis. We have some examples that we've been trying to do as well, like internally to add to our business value. So another aspect of this, so the analysis, just finding data is hard. Once you've found the data, you know it's dirty. There's always something going to be wrong with it. There's going to be missing values. There are going to be incorrect values. One of my favorite examples is when the data.gov released a bunch of Medicaid data, or maybe it was Medicare data about doctors and procedures that they were performing. Wanted to go out and actually find out if you could go from what procedures a doctor performed to what their primary specialty was. Turns out the data is kind of a mess, and you'd think that coming from the federal government with a very, very big budget for managing this data and releasing it and whatnot, they'd actually do some work on helping to make sure that it's reliable. You'll find the fact that some doctors just don't even have specialties, which is weird. You find that some doctors are 250 years old, which is extra weird. Turns out they're not actually 250 years old. They just entered, one of these people actually entered like 1773 or something like that as the date that they graduated from medical school, which there are other things happening around that time. I'm sure he wasn't in medical school. But the point being, it's hard to get, it's hard to process. Once you actually process it down to something that's clean that you can actually do your analysis on, it turns out that you're just kind of like approximating what you were doing because you had to go through so many assumptions as you're getting to the point where you had some amount of data that you can do your analysis on. And so finding the right question to ask is an iterative process that involves a lot of hard work. So that's all amazingly like 10 minutes of lead up as to what's one of the main motivation for Sahara. And the main motivation is to allow data processing itself and the management of the data processing infrastructure and tools to become so simple that the people actually who have to do the analysis don't have to worry about the tools at all. That kind of like big, crazy distribution graph of all the projects that are in Hadoop and all the services that are associated with it, they don't have to worry about that. They can just deal with the really almost intractable problem of doing data analysis themselves. So a little bit of history for Sahara. So Sahara is just over a year old. It was launched as part of the Portland Summit back in April of 2013. It was a joint effort between Mirantis, Red Hat, and Hortonworks, with the initial code drop coming from Mirantis, Hortonworks coming in and spending a lot of time working on kind of a plug-in architecture so they can make sure that their distribution worked well. And then Red Hat spending a lot of time working out some of the community aspects and then pushing through some of the one of the use cases that I'll talk to you about later, which is kind of like workflow management to kind of simplify things even more. It's incubated for the Icehouse release, which is out there now, and then in a couple months it'll actually be released as an integrated project. At that point, I'm sure you can start getting it from a lot more people, and I'll just leave that there. So the two big use cases that Sahara wants to, and does successfully to some extent, attack is one, cluster management, and two, workload management. Cluster management you can think about as starting up your Hadoop cluster, starting up your Storm cluster, starting up your Spark cluster, kind of managing its life cycle, scaling it up and down, starting it of different sizes and shapes and sizes, and doing it in a repeatable fashion. And the repeatable fashion is important because it means that the templating mechanism that we have, which I'll touch on later, can be set up by an expert, somebody who is actually maybe a Hadoop sysadmin or whatever, and then be given to users so that they don't have to worry about the proper configuration or the proper tuning for a cluster of 10 nodes or a cluster of 100 nodes or a cluster of 500 nodes or whatever. That's all kind of like baked in and single click for the most part. We could do a little bit better actually on that. The second use case is around workload management. So this is, you can think about kind of like job management. So this is queuing and running jobs where a job is basically some sort of analysis code, typically like a jar file, MapReduce code, pig script, maybe some Hive, HiveQL or whatnot, packaged together with some data URLs or endpoints that you're going to read from and write to, and then run across the clusters that are started up in the first case. And these clusters can be ones that your admin is set up as production, or it could be one where it's just you set it up for yourself as opposed to like a production multi-tenant cluster. Or you can even do kind of ephemeral clusters where you say, I want to fire off this job, it's going to do some analysis, and it'll create a cluster for you, run the job, when the job finishes, shut the cluster down, kind of a very elastic fashion. So to do all this, here's a somewhat detailed architecture diagram of Sahara and how it interacts and integrates with different projects in the OpenStack ecosystem. So which it does as a good OpenStack project, as opposed to like the Hadoop projects, which sort of integrate in one way or another and not necessarily on specific versions and all that kind of stuff. But when you're going out and using Sahara, you'll find that there are actually a handful of pages that are part of the Horizon dashboard for Sahara. In the Icehouse release, if you're doing this, you'll actually have to install a separate Django app and whatnot. It turns out just a couple weeks ago, right before we were going to say we were going to stop trying to do it, the Horizon folks managed to consume, like heroic effort, managed to consume many, many thousands of lines of our Django app, which we had been developing over the past year. So now it's actually part of Horizon. So for Juno, you just get Horizon, you have Sahara there, kind of out of the box. Of course, it uses the Python client API, or talks to the REST API, and internally we have a whole slew of kind of little internal services that are running. We're working to actually break these out so that you can have kind of an API engine architecture, which will allow for more HA capabilities and whatnot. Two things I'd like to point out here. Well, three things I'd like to point out here. One is the orchestration manager, which is kind of like in the bottom of the service box there. We have two implementations of this. We have our native, what we call a direct implementation, where we talk out to Nova and Neutron and everything and set up our cluster and whatnot. And then we have a heat implementation. Kind of like Austin mentioned, we had to go through a full cycle of spending a lot of time with the heat folks to make sure that there was feature parity between the two engines so we could actually switch over and not lose functionality, but that should probably be there for Juno, which is a good thing. Next thing to mention is the Trove DB. So Trove DB as a data source for instances and clusters that are started up has actually been on this architecture diagram since the beginning, and we haven't done a whole lot with it yet. So we should get on that, and maybe we can talk about some of that after this. And then the last thing is the vendor plugins there in the middle. The vendor plugins are pretty important to the Sahara architecture. They provide the place where vendors can actually write code that conforms to a rather stable API and make their distribution, be it commercial or free or whatnot, accessible and available to users. So it's the place where a user gets to decide, this is the type of cluster that I want to start up, the software collection or whatever, at a certain version level and whatnot, and then say, go, start up this cluster that looks like this vendor's whatever. And then from, like I mentioned, for a vendor perspective, it's quite important. I listed up here a handful that we have implemented at the moment. We call them plugins. So we have the vanilla plugin, which is kind of the reference implementation, and it's based on the Apache versions of Hadoop, both Hadoop 1 and Hadoop 2. When I say Apache versions, it means it actually goes and it grabs tarballs from Apache to install, versus the HTTP or Hortonworks plugin, which uses Embari and pulls down Hortonworks' version of Hadoop and all of the things in the ecosystem. We've recently had the introduction of a Spark-based plugin. It's kind of based on the vanilla one, so it pulls Spark from the Apache versions. There's a spec approved, so there's like a blueprint, plus we're doing a spec implementation for things where you basically design it out and get the design approved before you go and start doing the work. So there's a spec approved for CDH, which will probably land for Juno. And just a couple weeks ago, there was one that came in for MapR. That's currently in review. And then one that we had for the longest time was IDH, which at this point, if you're familiar with the Hadoop ecosystem, Intel threw a whole lot of money behind Cloudera and kind of shuttered their Hadoop distribution. So IDH is on its way out, which is also kind of an indication of the ecosystem that we're trying to drive around plugins. The ability of the vendor to stay engaged and involved in the actual project itself, so that there isn't really kind of like dead wood sitting in maybe decreasing the value or the experience that a Sahara user would have. So I mentioned the API before. Like any good OpenStack project, there's a pretty extensive API, both REST and Python. I'll go through some of the details of that since we're progressively getting deeper into Sahara in just a second. I would like to point out that it's obviously available through Horizon, so a lot of the actions that you could do in the API are available through Horizon. We're trying to smooth that out so you don't have as much of a developer interaction with Horizon as you might have just kind of like a user interaction with Horizon. Ask me later if you want to know what I think about that. And then through a command line interface, which most projects these days are supporting, which is good. So for the two main use cases, the cluster use case and the workload use case, from an API perspective, we have kind of like a set of structures, and I'm calling it here the basic structures, which more or less correspond to cluster management. So these are things like being able to interact with, select, install, identify plugins, the vendor plugins that the user might want to use to start up a cluster. There are images. I should point out here that the fact that there are images doesn't mean that Sahara somehow magically manages images itself. It actually uses Glance to manage images. What it does do is it allows plugins to kind of like specially tag images to say if the image is compatible with the plugin or not. What does that mean? Why is that relevant? You can think about, I said we have this vanilla plugin, which is a reference implementation that pulls down stuff from Apache. In fact, that plugin expects that everything's already pulled down using disk image builder elements and installed in an image, which is then uploaded into Glance. So if you give it just a bare image, the plugin wouldn't work very well because it'd be expecting to find Hadoop in its location that's not there. And you can contrast that with the HTTP plugin, which will actually operate in both fashions. One, you can have HTTP pre-installed. This tends to make things faster for startup and is really good if your cluster happens to be air-gapped for some reason. Or you can do just kind of like a generic enterprise Linux image, and part of the cluster startup will actually be to download all of the software, install it, and whatever, then stand it up. After that, the kind of like probably two most important things for cluster management are our templating system. And we have two types of templates. The first type we call node groups, and the second type we call cluster templates. You basically take your node group templates, combine them together, have some sort of cardinality associated with them, and make them into a cluster template. An example of a node group template would be like a master template that has like HDFS and MapReduce and Yarn master processes running on it, and then a worker template that has the worker equivalents of those. Combine those together to create a cluster template. And these are things that also have configuration associated with them. So you say, when you're maybe doing a cluster where it's got 1,000 workers, you're going to apply different configuration parameters to Hadoop to make sure that it can actually scale and be tuned to that size. And then the last thing here is basically just clusters, which is the live instances that you can manage of the cluster templates. So the second set of objects that exist in the Sahara space are for EDP, which is the elastic data processing, the workload management. There we really talk about data sources, and we talk about job binaries. We talk about jobs and executions. Data sources are things like URLs into Swift or URLs into HDFS. And these are places that your jobs can actually read data from and then write data to. We've got some special plugins for Swift or whatever that I can go into detail later about if people are interested. And then job binaries, it's like the MapReduce or the pig scripts, jar files or whatever that I was mentioning before. Jobs are kind of like the equivalent templates, like cluster templates, create clusters. Jobs here, the naming is a little unfortunate, are templates that create job executions when they're actually running, and then there's lifecycle management for all that stuff. I thought I'd kind of like, before we totally end here, point out the roadmap for Juno. So some of the features that you'll find, you can go to either one of these links to get kind of like the full list. But interesting ones to note, I already mentioned the dashboard has been integrated with Horizon. We've actually extended the Spark plugin to not just spin up Spark clusters, but to spin up, allow Spark to work for EDP. So you can write a Spark script in like Scala or something like that and say, run this against a cluster that gets created for you. I mentioned the CDH plugins on the way. I was a little surprised to see that the Storm, so there's potentially a Storm plugin coming along. There's a spec involved for it. However, there hasn't been a whole lot of code that's kind of gotten pushed through for it yet, so we'll see what goes on there. And then for kind of assisting with production Hadoop cluster deployments on OpenStack, there's been security work both in having Sahara be able to manage security groups for you, so we know what services are starting up on instances, what ports they require to be open, and then we can create a security group that works kind of minimal port interaction for your cluster instead of doing what everybody does right now, which is just all open. Enjoy. And then we're doing some work to make sure that the interaction with Swift is more locked down than it is right now. Right now, you have to actually give credentials to Sahara so that it can access Swift on your behalf as part of your job execution. In the future, we're doing some stuff potentially with tokens, maybe not with tokens, maybe with temporary users or whatever, just interacting, having fun with the Keystone folks to work on that. So with that, all these slides are already up on SlideShare. You can just Google for SlideShare, Spinning Mat, Sahara, they'll probably show up. And then there's a link to a kind of a demo video if you want to watch me click through everything with not a whole lot of sound. Maybe I'll update that later. And then that's it. Questions? Yes. And I didn't quite understand. The question was, what is the Trove DB box on this architecture diagram? It's dotted in that it's something that we want to implement in the future. And it represents when you're actually running some workload in a cluster, that cluster may itself be ephemeral, which means that it doesn't have the data that you want to be processing already in the cluster. So you need an external data source to pull it in. You can kind of think about this if you're familiar with EC2, like having data in S3 using EMR and pulling it in. So we do that for Swift so that you can have objects in Swift that are input to your jobs. We think it would also be useful to be able to have tables that are deployed somewhere in Trove as endpoints for an analysis that's actually run inside the kind of Sahara managed cluster. So it's kind of like have Trove here, have some data that you know that you want to do some analysis with. You have Sahara on the other side, and when you say fire off a job from Sahara, you pass in an endpoint that'll let the job interact with Trove directly. There's a Hadoop compatible kind of file system API or whatever in play that we have for Swift and could actually work with Trove in some cases. So yes.
So is it more about ETLing data from outside, or is it more about, sorry, is the Trove DB box more about ETLing data from other data sources into the Hadoop VMs, or is it more about the interfaces, having the Trove interfaces present?
So it's definitely about having the Trove interface present and accessible to jobs that are running inside your Hadoop cluster. If it's about ETLing or if it's about pulling data out to do some sort of analysis, I would say that's up to you as the person who's trying to do that really hard job of analysis, if you should be pulling it in or whatever. We don't really want to, we're not prescriptive on that.
Other questions? I had a question actually.
Yeah.
So one of the things that we see in the Trove architecture is that there's kind of this clear distinction and kind of a barrier of saying, what's data path and what is kind of management control path. I was just wondering, does Sahara have a similar distinction, and does Sahara try to stay on one side of the
we're primarily through the control path for the analysis for the programs. There are some places where we actually the analysis tends to run best when the data is also kind of like managed under the same umbrella. HDFS is a good example. The MapReduce framework likes to be co-located. We actually have a number of features for making sure there's co-located data, even if the data is in Swift. And the same thing for things like HBase or Hive, which kind of like work as another abstraction on top of the data that's typically stored in HDFS. So it's not a super clear cut line. We try to walk it effectively.
Sure. Other questions? Oh, great. Well, thank you very much. Great job.